I'm Steve Johnston, co-founder of A Race Against Blindness. Our nonprofit mission is to provide awareness, advocacy, and help support fundraising for sight-saving research. As a part of our awareness and advocacy efforts, I'm excited to share with you a conversation that I got to have with Dr. Phil Beales, a leading researcher and clinician on Bardet-Biedl Syndrome. I hope you enjoy our discussion. So it is a pleasure to finally have you here in person. We've had many conversations about the work you're doing, our organization, but I really am excited to provide this resource to the Bardet-Biedl community and get an introduction to you. So without further ado, can you tell us who you are, what your background is, and a little bit about your clinical practice?
So Steve, yes, it's a pleasure to be here as well. Thank you so much. My name is Phil Beales. My background is in medical genetics and molecular genetics as well. But really, I believe that my major contribution has been towards better understanding Bardet-Biedl syndrome. And I've been doing this for well over 25 years now. And it was one of those situations serendipitously where I met a patient for the first time in London. And that's really just led to a whole snowball career in this area.
Wow. Okay. Well, that definitely takes me to the next question, which was exactly how your career did unfold and what that specific interest that led you into ciliopathy and Bardet-Biedl syndrome.
Yeah, like all things in life, you don't expect these things to come around the corner. But it just takes me back to when I was a junior doctor. I was working in endocrinology at the time. And in fact, I was working at the Royal London Hospital in the East End of London, which is famous for the Elephant Man and also another local person, Jack the Ripper. So in essence, I was called to the, we call it A&E, accident and emergency room, one evening when I was on call. And there was a patient in a coma. And so it was my job to resuscitate this guy. And essentially, when we had resuscitated him, I put him onto the high dependency unit, went back later on to, complete my checks on him and everything. And he'd woken up. And in essence, he had diabetes, and that was the reason he was in a coma.
Right.
He had what's called in the medical parlance ketoacidosis. So insulin sorted him out, and he woke up, and we got to speak to him, and it was very clear that he had no vision. He was significantly overweight as well, and he also had scars on his hands as well, where extra fingers had been removed, and I just happened to be doing some advanced level exams at the time, and it rang a bell with me. And what it was I kind of went back to my on-call room, checked my lecture notes, and there was this disease called Lawrence Moon Bardet-Biedl Syndrome, which is big mouthful, and hardly anything known about it. It also happens that I was working on the genetics of obesity at a time in the sort of late 90s when it was becoming more recognized that obesity could be genetically driven. So I figured from this particular, by understanding what had gone on with this guy, and then understanding that there must be a condition out there that is caused by what was known at the time was caused by a single gene. Mm-hmm. Whereas what we knew about obesity and diabetes, many genes cause those particular problems. So in essence, the opportunity there, I recognized the opportunity there that, with this guy, he was called Terry, we were able to begin a journey where literally I contacted all of the pediatric departments in the country, all of the ophthalmology departments in the country, and nothing came back. Mm-hmm. So I kept going, and eventually we got one or two, letters back and so forth. And so from that kind of built up an early register in the UK. And then I got in my car and went visit all these families all over the country, and we built a kind of a a blood bank and a DNA bank on the back of that.
Wow. That's an incredible story to hear kind of how that all came together. So you hit on a lot of stuff with Bardet-Biedl syndrome, all these different symptoms, the diabetes, the weight gain. You mentioned the extra digits or polydactyly and the vision loss. So can you tell us a little bit about what Bardet-Biedl syndrome even is and its prevalence and how common it is?
Yeah. So it's a complex disease. I think it's really important to say that. And it's complex because it affects most systems in the body, if you like, in one way or the other. But the most prominent ones are obviously around vision loss and weight gain. But there are other issues that arise from time to time, such as kidney problems, cystic kidneys, for example. And there are also elements of variable learning difficulties and often behavior issues such as autism and so forth. So, as I say, it is a complex condition, but you could say that the most striking components are the early onset vision loss. So that might start at around 4 to 6 years of age in children. Might manifest as night blindness, a difficulty seeing in twilight and so forth in dark areas, and then of course often quite early. It's a bit variable, but quite early on, within the second year of life, a lot of these children will develop a voracious appetite, so-called hyperphagia, and that is probably what's driving this lifelong almost obsession with food and therefore weight gain.
Yeah. Well, we are parents of a child with Bardet-Biedl syndrome, so we can certainly attest to some of those things. And the vision loss is certainly the most striking and kind of frightening as a parent to go through. But certainly the hyperphagia is a really difficult one to manage because it's really two-pronged, which is you worry about the outcome of what the weight gain will do to them medically, but the hunger is a real day-to-day challenge as parents, dealing with, a child who wants to eat, and it pains them to not eat. So how you manage that as a parent is just heartbreaking sometimes. So it's a really big issue. So you mentioned, patients that you see. So what's your clinical practice like? How many Bardet-Biedl syndrome patients have you seen? Kind of what's your experience as an expert in the field?
So really historically, from what I told you about the history of, getting in my car, going around seeing families and so forth. So that started to integrate into my general genetics clinics, where people would then refer patients with BBS to us. And then it got to the point where about 15 years ago, we realized that this needs a specialist clinic all of its own. So, we have an integrated healthcare system in the UK, a nationalized system, and there was an opportunity at that time to apply for kind of a nationally commissioned service. And indeed, that's what we did. We put together a specification and said, look, this needs a multidisciplinary team to take care of these patients. And the other thing that we needed to do was needed to provide lifelong care. Because as you know, with most pediatric diseases and certainly rare diseases, they get lost to follow up when they're in their teenage years. So we wanted to make sure there was a transition. And so we were awarded that clinical service. It runs out of 4 different clinics, which is kind of geographically spread throughout the UK. So we have, so people don't have too far to travel to centers of expertise. And we'll have at each of those clinics 7 specialists, slightly different from the adult clinic to the pediatric clinic. But the pediatric clinic will have a clinical psychologist, a kidney doctor there, an endocrinologist, a geneticist, ophthalmologist, where they have the full workup, dietitian, and then at the for the kids, we also have a speech and language therapy specialist as well. We mirror most of that in the adult clinic, but we don't have the speech and language person as well. So it works very well because when the child gets to 17, then they transition across and they have some of the same clinicians in the adult clinic as well. So, and that gets mirrored. So we have two clinics in London, one at the Children's Hospital and one at an adult hospital. And then the same goes on in Birmingham as well, up north. So again, with the same transition program. Wow. So the beauty is that the same management is applied across all of those services. And more importantly, the same data is collected.
Yeah, fantastic. So how many patients do you have registered in that BBS clinic that you guys are regularly kind of treating and following?
It's about 700 patients.
That's a lot. Wow, that's impressive. And what's the general current belief on how many patients there are that have Bardet-Biedl syndrome, and has that changed over time?
It has changed a lot. If you look at the old books on this, it was considered super rare, ultra rare. Mm-hmm. And you get figures of like 1 in 160, 1 in 200,000, for example, some old papers from Switzerland. Then it moved to about 1 in 100,000 a few years back. And we've recently done some analyses using some of these publicly available genomic databases. And it seems it's a lot more common than that. So we're talking in the West, probably around 1 in 72,000. And still rare, but we're not talking like 1 in a million or anything like that. You go to other places such as the Middle East, where there are higher levels of consanguinity, and you'll find it's about tenfold more common. So, for example, about between 1 in 10 and 1 in 13,000 in, say, Kuwait, for example. And so, yeah, there are pockets around the world, but it's found in pretty much every community around the world can possibly find. Yeah. Faroe Islands, for example, is like 1 in 3,400 people.
Wow. Yeah. I had no idea.
Yeah.
So what does that translate to in terms of total like active prevalence that you would guess that are out there right now that have BBS?
So as I say, probably the working number would be around 1 in 72,000, which equates to around, well, if we take the North America, Europe, and say the Middle East as well, for BBS1 alone, which is one of the subtypes, we think that's around 25,000 patients. But if you take all of them all together, we're probably talking around 50,000, something like that.
That's fantastic to know, because I think there's a big, feeling that when you get diagnosed with this as a patient or a family, is that it's this rare disease that nobody else has and you feel kind of alone. But knowing that those numbers are there, it really changes the community aspect of it. So that's really important to know. So obviously this has been evolving over time. There's been a lot more, knowledge gained. So what has has there been any advances in treatments, therapies, and what currently exists for patients with BBS as of right now?
So, as we call it, the standard of care, there isn't really a standard of care. It's conservative treatment, as I call it, or conservative management. You deal with the diabetes as it turns up. You deal with the weight, with diet, exercise. Things are changing more recently, obviously, and of course, any of the other problems such as kidney failure. We're talking about kidney replacement therapies. In those situations, I mean, I have to say it's a minority, thankfully, of patients who do reach that level. But at the same time, there's nothing special that is specifically out there for BBS per se. However, where it is starting to change is in the area of weight management and hyperphagia in particular. So, as we all know, there's a lot of excitement around new therapies that are out there, the so-called GLP-1 agonists. And there is one treatment that has now been approved specifically for BBS, but there are other diseases in the same sort of category as well that drug treats as well. It's called setmelanotide, and that helps to quell the appetite, and that has some significant benefits as well.
Fantastic. So, as a family that's gone through this diagnosis, and when we found out what our son Luke has, that was our first question: was what can we do about it? What's going on? And it sounds like, as we know, and you've confirmed, that there isn't a lot that's currently being, is available for treatment for a lot of the stuff related to BBS. I know that you're doing a lot of work. So can you tell us about, your history in researching BBS? Because you're more than just a clinician. I know you're a researcher. So what's your research look like, and what's that kind of pathway looked like on the research side of the BBS?
Yeah, so back in the day, we're talking late 90s here. The obsession was with finding the gene. As a geneticist, you just thought about finding genes. And it was hard work in those days. I mean, it took years to find a gene. So I had created the sort of the bank, the DNA bank in the UK, and the registry. And the problem was, I don't need to go into the details of how you do this, but the more families you can find, and more DNA to play with, in other words, the more likely you are to find the elusive gene.
Right.
So I contacted a guy called Jim Lupsky at Baylor College of Medicine in Houston, who also had published and collected small families, but lots of them. And so we decided we would combine. So I moved to Houston, to Baylor, and we essentially found the first gene there. And we published that in the same journal. And when we opened the journal, there was another paper for exactly the same gene from a different group. So, but we can still claim that it was the first gene that was to be found. It's called BBS6 or MKKS, which is one of the rare ones, to be honest. But it really led to the beginning of a whole field that has really mushroomed. And that led us to the point where I had to make a decision. Should I go back to the UK or should I stay in the US? There were opportunities to do that. And what I wanted to be able to do was to say, right, okay, do I go back to the clinic or do I go back to the lab? And I decided to go back to the lab and open my own lab in London. And its mission was not only to find, well, we realized that when we found the one gene, there were many more genes to find. Yeah. So then we launched upon finding more genes. But then what's the point of finding genes if you don't actually find out what the genes do? Because genes generally are there most of the time to make proteins. So therefore, what does this protein do? Right. And so I remember very distinctly when we found this gene, it was about 3 a.m. on a Thursday. And we looked at the scan or the gel, as it were, and we thought, this is it. This is the gene. So the first thing you do is and back in then, the databases weren't so good, the public databases, but the first thing we went in is to compare the sequence with anything else out there to see whether that gives you a clue as to what could be causing the disease. Couldn't find anything. We did find something. It was a bacterium called Archaebacteria. So first thing we knew is this is a highly conserved in nature, so it must be important. But that didn't really give us any clues. And it was really until other people found other genes, and then we found a gene a few years later in around 2002, 2003 called BBS8 at the end of the day. It's called TTC8. And that's what really gave us the clue. And that was because the primary family that I was studying in the UK, who were of Pakistani origin, there were 3 brothers who all had Bardet-Biedl Syndrome and mutations in BBS8. One of the brothers, the oldest brother, had his internal organs switched in a mirror fashion called situs inversus. Yep. And for me, that was a bit of a strange finding, because I'd noticed in the database there were several other individuals who also had that in other families, more so than you would see this happening by chance in the general population. So that, coupled with visual loss and the kidney cysts, I looked into as a group, we looked into with my collaborators, the background information around how those things arose. And it was about, it was late 90s, I think it was, that information was starting to be published around how laterality, in other words, the positioning of all our organs, is so uniform. Mm-hmm. So with our liver on the right, spleen on the left, heart pointing to the left, all that kind of thing, 99.9% of people have that positioning, and how does that happen? So without going into the super detail around this, in essence, this goes back to how the embryos in all vertebrates, all backboned animals, at the embryo stage, there's essentially the first signs of cilia appear a very few days after fertilization.
Okay.
Talking about 10 days after fertilization, thereabouts. And in essence, these cilia spin and they move fluid to one side. And then it's immediately within a few hours after that particular point that what's essentially a symmetrical embryo, doesn't have a back, front, left or right, suddenly starts to turn in a particular direction and then starts to form the fetus that we eventually get to know. And when that process goes wrong with the cilia, then you leads to this business of organs being positioned on the wrong side. So it was that observation coupled to the fact that cilia are important or cilia dysfunction are associated with cysts in the kidneys, and the fact that there is a connecting cilium in the photoreceptors in the back of the eye and the retina, that was the aha moment. It was essentially like cilia have to be causing Bardet-Biedl syndrome. So that really led us to doing a whole bunch of work to prove that. And we published that work and we carried on for many, many years understanding what was going on. Also, it led to understanding a lot of other diseases in the ciliopathy category as well. So we found a number of genes for other conditions that included skeletal dysplasias and those kind of things, which are also ciliopathies. So BBS is the archetypal ciliopathy, essentially.
Wow. Well, I mean, I guess the first thing to say to all that is thank you, for putting in your life's work to this rare disease and, learning something that nobody else was looking into at the time, because, that takes, a special, dedication and passion for what you're doing. So as a community, it's, something that we all just want to thank you for putting in that type of work. In terms of, that lifelong work, going from understanding, learning what it is, how it came to be, the effects that it has on the body. So what has that pushed you into in terms of your later years of your career with research for any type of potential therapeutics or otherwise?
So I set myself a goal and, we've done the gene discovery. We've worked out what the proteins do to a certain extent, what the mechanism that leads to all the problems, or some of the problems, should I say, that occur with BBS. What about a treatment? So I never thought that I would ever live to see the day when we could treat rare diseases.
Right.
Back in the day, monogenic disease, how can you possibly change that? And of course, gene therapies came along. And so about 13 years ago, I set up a group in my lab, one section, if you like, that would be focused upon developing gene therapies for this and the possibility of doing this in both using cell models and also other organisms as well. So Victor Hernandez, who'd been in my lab for many, many years, he led that program.
Okay.
And we, from there, we developed and showed the proof of concept in what we call the non-clinical setting, that gene therapy could indeed prevent continuation of visual loss. So in other words, halt it in its tracks. So of course, you've got to give it at a certain stage, but in order to be able to maintain good vision.
So can you tell us what some of that research has looked like in terms of like animal models or testing for preventing vision loss?
Yeah, so we work with cells, for example, and we can use a certain type of stem cell, for example, to build either a kidney or an eye in a dish, and we can do research on that. But there is still nothing that replaces the gold standard, which is an organism such as a mouse.
Sure.
And we are fortunate that, we've made a few mice along the way. When I say made a few, generated the particular condition that emulate the human condition. in that particular mouse. And this doesn't always work,
Mm-hmm.
but we've been extraordinarily lucky with Bardet-Biedl Syndrome mice because they do emulate the disease pretty well, in the sense that they almost all develop early onset visual loss. They become extremely overweight, and they even have some of the behavioral elements. One thing they never seem to have is extra fingers or extra toes, but who cares?
Interesting. So do you have any publications on, treating the vision loss in these mice models, or any upcoming presentations that will be available that people can look into to learn more about it?
Indeed, yes. We have a presentation coming up at the American Society of Cell and Gene Therapy just next week, in fact. We have a poster there describing the visual rescue, if you like, or the prevention of the visual loss in mice. And so this is where we've undertaken a number of experiments to look at the back of the eye, the function of the back of the eye, and the anatomy of the back of the eye.
Yep.
And what we essentially do is we will deliver the gene therapy into one eye and leave the other eye untreated. So it's like an internal control.
Yep.
And we can watch the untreated eye degenerate in time, as you'd expect it to do, and then compare it with the treated eye. And what we were able to see was that the treated eye did not degenerate in the way the other eye did. In fact, it maintained the structure, maintained the thickness of the retina at the back of the eye, because it gets very thin with time. But also, more importantly, we were able to show, using some of the functional measures, that these mice are probably able to see. They can't tell us, obviously, but they're probably able to see out of that eye as well. But most importantly also is the fact that this lasts a reasonably long time. Mice don't live very long. They live only a couple of years. And for the majority of that period of time, they seem to still be able to maintain vision out of the treated eye.
Interesting. So I don't know the answer to this. Is the mouse a kind of a scientifically proven model for human vision conditions? And has the mouse been used in other, ophthalmology research or vision loss related conditions that's been kind of a proven model?
Yeah, it has in lots of studies.
Okay.
I mean, a lot of people have. It's the first model they would turn to, is the mouse model, right? But in some other diseases that have led the way, because there aren't very many approved gene therapies for vision loss, for example. And they, in the early days, had to resort to larger mammals, should we say, to be able to prove the point. But I believe that these days, mice are probably likely to be good enough, depending on discussions with various regulatory agencies. Yeah.
Oh, that's interesting. Because as a kind of a patient, family, and community is like, does this translate from mice to humans? Of course, is kind of that big question.
I mean, indeed. I mean, there are differences in the structure of the mouse eye compared to the humans. So depending on which part you're looking at, the retina in particular has enough similarities to give us confidence that this is likely to work in humans as well, patients, and there's a lot of other studies that have gone before that have demonstrated that.
Fascinating. Well, that's certainly really kind of reassuring to hear. So we talked about that, BBS is a multifactorial disease. It affects multiple different organ systems, kidneys, eyes, and obesity, as you mentioned. You've done obviously a bit of work on the eye related. Are you or anyone else doing anything related to the hyperphagia component of BBS?
Yes, we're doing that as well. We are particularly interested in developing therapies that can deal with the hyperphagia component, because hyperphagia is, for someone who doesn't understand what it's like to be hungry all of the time, it's, from my discussions with lots of patients, it is hugely debilitating.
Yeah.
I'll sit in clinic and be speaking to parents, for example, and some of these children find it very difficult to sit still and watch. I mean, sit still and are asking for food.
Yes.
Or watching food on their iPad.
Yeah.
And so when you speak to adults, speak to children, they say that every waking moment is essentially devoted to thinking about food. So there is a need to get on top of that.
Yes.
And, there is promise with the new drugs that are out there at the moment, but they have, from what we can see so far, they probably have limited value.
Okay.
In the sense that you're going to have to take those medications for a long time.
Yep.
At the moment, most of them are daily injections. Some of them are obviously weekly injections, but that's for life.
Yeah.
Until something else comes along. And so what we're trying to develop is the something else that's coming along, which is a one and done therapy.
Yeah.
To essentially normalize the weight. And this is what we've seen in our mouse models. As I said earlier on, the mouse is enormous compared to their normal
Yep.
littermates. And what we were able to do when we administered the same gene therapy as we're giving to the eye,
Okay.
we administer that to the brain, into the fluid in the brain. And those mice completely normalized their weight. We couldn't distinguish them when we looked into the cage from the normal mice that didn't have the genetic mutation. So that gave us a lot of confidence that, this could potentially work in patients as well.
Wow.
And so that's where we're now aiming toward developing therapies around that.
Wow. I mean, that would be certainly groundbreaking, from our standpoint as a community, knowing the effects it has, what you talked about with how debilitating the hunger aspect is, and then obviously preventing, the negative sequela of what, obesity does. I mean, that's something that's going to not just improve the quality of life, but massively impact the longevity, preventing diabetes, hypertension, fatty liver disease, all the things that comes along with it. So that's really something that, as a parent, as a physician, is a huge concern. So like knowing that there could be something for that would be absolutely important to keep, working on further. Is that type of therapy going to be applicable to anybody outside BBS, or is there anything similar to that could be?
No, it will only be applicable. Gene therapy is only applicable to patients who have a spelling error in the gene in question. So in this particular instance, we are looking to develop or are developing gene therapies for a subtype of BBS, which is BBS1, which is actually the most commonly mutated version of BBS out there, at least in the Western world. And, but there are 25 different genes out there, and probably more, to be honest. So you got to start somewhere. So we're starting with that one.
Fantastic. So you alluded that your goal is, over the course of your career, starting from, learning the basic science to now ultimately having that goal of finding a therapy. So I know that, clinical trials, all those kind of things are, a work of art and take many things to make happen. What are you able to tell us about your mission to actually make this a reality for a therapy?
Yeah, well, we're at a point where we've had to think hard about how we're going to develop a new therapy. And as I said, my lab at UCL, we've developed a lot of the understanding around this disease, and we also developed the initial part of the gene therapy, but it's an expensive process. Yeah. So we decided in 2020 to develop a spin-out company called Axovia Therapeutics. So I'm the co-founder with my colleague, Victor Hernandez. And it's our mission in that company to create these gene therapies and to take them into clinic. And our aim now is that distant objective is now that much nearer. So we're hoping, we can't say for certain because there are so many complexities involved in the whole process, including getting approval from the regulatory agencies. We are hoping that we might get into the clinic, start clinical trials in the middle of next year.
Wow. Well, thank you for your work to make that happen. And thank you for sharing that. It's really exciting as a community here that there is, something in the works and that there is potential, hope on the horizon. So yes, I know that there's so much to be done and so many unknowns, but it's really great to hear that update. So thank you for sharing that. So turn it around to you. What questions do you have for us? Do you have anything that you want to ask? I run a nonprofit organization, A Race Against Blindness. We're parents of a family with a child with BBS. So any questions that you might have for us?
I don't have too many, but one thing that is always at the back of my mind is around what the expectations are of the patient community, because there are a number of issues that we are actually, I guess naively on my part, didn't appreciate would arise. So, for example, we've talked about BBS1.
Mm-hmm.
Now, if you have a genetic mutation in another gene, BBS1 therapy is not going to help you.
Mm-hmm.
But one day maybe there will be a gene therapy for those other ones, but they're quite a way off because it takes a long time. And what do you know about the community's view on this particular problem?
Yeah, certainly. So, I mean, I certainly don't want to say that I speak for, everybody who has a BBS diagnosis, but we've certainly connected with many people who do. And we've certainly talked to many people just in general in the vision loss community, just any cause of retinitis pigmentosa or otherwise. And I think that the general consensus is that everybody is really supportive of research. They're hopeful for a cure. And I think there is a general understanding that advancing one treatment is going to lead to an advancement in another and another and another, and they snowball. So Leber congenital amaurosis is certainly the first major, inherited retinal disease to get a gene therapy to halt the vision loss. And I know that is, provided a basis for some of the work that you're doing.
Exactly.
And my hope as a nonprofit organization and as an advocacy group is to be able to keep working with scientists, regulatory agencies to make sure that treatments are accessible so that these rare diseases don't get left out for financial reasons or otherwise because the patient population isn't big enough. So with, further approvals of new therapies, can we work with the FDA or other regulatory agencies to say, how can we streamline this process to get more therapies to these patients who are otherwise going to be left out? And that's, at the end of the day, wrong. Yeah. And so that's one of our missions. And I think one of the roles that hopefully we can play in terms of continuing to make sure that that advancement continues. But from a community as a whole, I think that they understand that each of these are going to be, their own unique, trials and processes. And, but they're in general support of any advancement in this area, because for so long, we've all been told there's nothing you can do. This is going to happen to you regardless of what you do, and you just have to live with it. So any advances, I think, are really welcomed and important ones to us.
Thank you. A second question I have really is around the concept of hyperphagia. So there's this fancy word, medical word for this voracious appetite that we talked about a little bit earlier on. And tell me what you think about the way in which physicians in particular view this problem, particularly in Bardet-Biedl syndrome patients.
Yeah. So it's really interesting. So we've put ourselves out there as kind of a face of this disease and shared our story and tried to be very open and transparent with, the challenges we face as a family and what our son has. And we actually just this morning got an email from a hospitalist physician who saw his first Bardet-Biedl patient ever. And he had been following us. He knew about us beforehand and was following the work we were doing. And he's like, I saw them and I thought of you. And I was immediately like, okay, I need to learn more about this. I need to educate myself. And so he was asking us, like, what resources exist? And I told him, I'm like, well, we're about to interview one of the leading researchers today. So we're going to be putting out more educational content to try to help people be aware of this. But I think from a hyperphagia standpoint, I think it really needs to be thought about differently than other causes of obesity because, some of the lifestyle stuff that goes along with just general, societal obesity is very different because this is a true underlying, leptin receptor deficiency that's leading to, this constant hunger that is driving patients. So I think the way you manage them is really different because you have to kind of, what we do with our son particularly is we're constantly kind of teaching him like, hey, you may feel hungry and your brain may be telling you that you need to eat, but your body actually has enough energy. It has enough fuel. It doesn't need more. So we're trying to always kind of coach him, be like, okay, I know you're hungry, but like you've recently eaten. So we kind of keep track of his meals through the day. And he's like, okay, I ate breakfast and it's not lunchtime yet. So even though I'm being told I'm hungry, I'm just going to try to wait. And that's much easier said than done, certainly, because the hunger part is very real and very painful. And especially for a child, as you know, kids can get very angry and very upset when they're hungry. Anger is obviously very real. So it's a very challenging condition to manage. And that's certainly one of the hardest things as a parent, depriving your child sometimes of what they want or what they feel like they need. So it's just a very complex aspect of it. But, from a management standpoint, it really is more of a, educational component of like, how you coach those kids through that moment when they're hungry and knowing that they don't physically need the food yet. So yeah, it's a very, very tough problem.
Yeah, no, I absolutely agree. In my understanding of what I've heard from patients, adults and children alike, and one of the other problems that they're constantly concerned with or come up against is the lack of understanding amongst the medical fraternity. Right. They don't. Many of them don't appreciate that there is a genetic form, right, if you like, a highly genetic or what we call monogenic form of obesity. And there are several out there, in fact, up to 15%, I believe. And they all get mixed up into the overarching narrative, which is, okay, people are lazy or they need to, get out a bit more and all this kind of thing. Mm-hmm. So would you say that applies to children or even adults with BBS?
Of course, the same general rules apply that, you have to, be active and, try to, have a, healthy lifestyle. But, the underlying cause of it is obviously very different. This is one of the true genetic causes of obesity. So treating them the same way in terms of just like, hey, go just watch what you eat and go diet and go, exercise. It doesn't apply. That just isn't the same thing. You're treating, the clinical syndrome of obesity, as if there's just one underlying cause, and that's simply not the case in this scenario where there is just a physiologic drive to need to eat because they simply don't feel full because their leptin receptor isn't working. So, it would be like saying patient has pneumonia, we're going to just, treat them with whatever. But like, you have to understand what the underlying cause of the pneumonia is. Is it a virus? Is it a bacteria? Is it, some other thing, so you always have to look at that underlying cause of what the clinical presentation is. And in this case, the clinical presentation of obesity is driven by a very different underlying cause. So understanding that will definitely change management and your consultation and the consultants that you bring in, who you have to help you with it.
Yeah. Amazing.
So, well, thank you so much for coming here and educating us about it. There's so much I learned just sitting here and talking with you. Our community is ripe for wanting more information and getting more resources about what's out there and for what's to come in terms of any therapeutics. But I want to say a special thank you because as of this recording, I had to wait till the end on this because I knew I was going to get emotional about it. We have 36,883 people who have donated to our organization. And the reason that they are there is because you have given our community hope. And we thank you for giving us all that hope. That's 36,000 people who believe in this mission and curing this disease. So without further ado, thank you from all of us.
Well, it's my pleasure to be here, meet your wonderful family, and thank you very much.
Thank you. I hope you found our conversation with Dr. Phil Beales both educational and hopeful for the future for patients with Bardet-Biedl syndrome. If you found any of this useful and you want to learn more, please head over to our website at eraceagainstblindness.org where you can learn more about the work we're doing and ways that you can help support our mission.